Yesterday, we left with this question. Okay. Which you gave us that answer. Okay. What does the negative sign communicate? Direction. Okay. There we go with that. Now, follow-up question. This. Will it always be the same? Will it always be opposite? Or sometimes it's the same, sometimes it's opposite? So mathematically, a way to answer that would be is it possible for delta t to be negative? Tell your neighbor yes or no, and why or why not. What would happen if delta t was negative? What would that mean? You're doing what? You're going back in time. Your final clock reading would be less than your initial clock reading. Not going to happen in physics, at least in this class. Okay? So your delta t will always be positive. So whatever the sign of displacement is, that's always going to be the same sign as velocity. Okay? So if you are walking this way, you have a positive displacement, you have a positive velocity. If you're walking this way, you have a negative displacement, you have a negative velocity. They will always have the same direction, always have the same sign, velocity and displacement. Good with that? Tell your neighbor.
It's just direction. Just the notification. Yeah, that's the number. Yeah, so the negative is so it's either. No, it's.
Correct answer is B. Beautiful butterflies. Okay. The magnitude is simply the absolute value of that measurement. Okay. Talked about that yesterday. Magnitude, absolute value. Okay. Have a conversation.
Well, that's D, so both A and B.
Oh, yeah. I'm just I'm an alien. I'm not. I was looking at 3 seconds.
Correct answer is D. Okay. So, this is different than math class, where in math you're going to say that positive 4 is going to be greater than negative 7. Okay. Sorry. Positive 4 and negative 7. Okay. Not on a number line. Okay. The magnitude is the magnitude of velocity is the speed. The mom's going 7 meters every second versus the baby's only going 4 meters every second. And they're going in opposite directions. Good with that? Okay. All right. So, most of what we've done so far has been conceptual, just getting an idea of what velocity, displacement are and how that's different than speed and distance. So there's a math side of physics. Okay, it looks very story problem-ish. Okay. There are some strategies that I'm going to try to develop in your approaches to problems. I will let you know that some of you have the mathematical prowess to be able to look at this, read the problem, and figure it out intuitively. That's fine. You need to communicate what you're doing now. But I will let you know that this is the only unit that will fly. Next unit, if you try to do this intuitively, you're going to crash into a mountain. Okay, so my recommendation would be learn how to set it up because time is coming where your tuition is going to fail you. Okay? So, for most, like the rest of us who don't get it intuitively, here's how you do this. Okay? You're going to draw a picture. So, scenario: a tourist is fishing, looks up, sees a bear 26 meters away. Looking at him, he decides to make a break for it, bolts to the car, going 4 meters a second. All at the exact same time, the bear goes after him, trying to catch him. What is the furthest position that the tourist can be away from the car so that he reaches the car just as the bear reaches him? Okay. So, draw a picture. It does not have to be elaborate. I kind of like drawing, so it's like I kind of do things a little bit more. You can just draw a box and write bear. And then you have the tourist. And okay. You know, bear's 26 meters away initially from the tourist. You know, the bear going 6 meters a second. Tourist is going 4 meters per second. We're looking for how far the tourist is from the car. Okay. Subtle detail. If the problem doesn't specify which direction is positive, my strong suggestion would be make the direction that they're moving positive direction. You don't have to deal with negatives. Avoid it. Okay. So, this next statement I give you is a really good statement that you're going to use for a while. If there are more than one object or there is more than one type of motion, then more than there must be an equation for each object in motion. If there are more than one, there is more than one object, if there is more than one object, and there is more than one type of motion, then there must be an equation for each object or motion. Must be a setup and equation for each equation, for each object or motion. What in the world do I mean by that? Well, how many objects do we have moving here? 2. I need 2 setups. I need 2 equations. Okay. At this point in your physics understanding, the only equation that you have really is that one. So we're going to be using that equation twice. So we have 2 different objects. Okay. So we have the bear and we have the tourist. Okay. What do I know? What variables do I know? What things do I have numbers for?
That's the very first one.
Yep. I've got the velocity of the bear, 6 meters a second. I've got the velocity of the tourist, that's 4 meters per second. The little sub B and sub T are just labels, subscripts. Bear, velocity of tourist. Okay. All right, good. Now, I am looking for the displacement of the tourist. How far the tourist can be away from the car. I've got this 26 meters. I got a number. That's kind of inviting. It's like, ooh, I want to do something with that. I'm like, that's a piece of information. Tell your neighbor how you're going to incorporate 26 meters into this setup. Have a conversation.
I feel like it might be how long it would take for the bear to get to the key person.
How would we find that? So,
Like, see how long it would take the bear to get where the person is at.
that was my worst thing.
Okay. What should I do with the 26 meters? There should be some confidence there. Like after you talk to each other, like, yeah, that's pretty good. Nothing? It's probably extra information. We don't need to know that. Yeah, we can ignore that.
Should we try and figure out how much time it will take for the bear to get where the person's at first, and then see
Okay.
from there?
That's the intuitive route. That's not wrong, but it's not the way I'm going to go. I'll hit that in here in a second. Everything stops at the car. How far did the bear run?
At least 26.
Yep, and then some. What is and then some?
What's that?
Okay, so the displacement of the bear is 26 meters plus the displacement of the tourist. How are we doing with that? Okay. Now, I've got the bear moving. So in an equation for the bear's motion, the tourist is also moving independently. So an equation to describe that. It's the same equation, but they're different variables, they're different values for what I'm plugging in there. Right with that? Okay. Now, what have I not addressed at all? The time duration. Change in clock reading. Okay. Do I have any values for that? Am I given any numbers for delta t? Great. Can't be done. Okay. So here's my question. Who is running for a longer period of time? The bear or the tourist? Or are they running for the same amount of time? What you think? Talk to your neighbor. Tell them why you think so.
No, because they get the car.
First, supposed to get to the car, once they're
He's just, he's running farther, but he's also running
time,
faster.
they're gonna stop. Start and end at the exact same time. The bear just runs fast.
Okay. Who's running for a longer period of time? Bear, tourist, or the same? Same. Ready? So I'm not asking who runs for a greater distance. Asking who runs for a longer period of time. Ready, set, go. Done. Not distance, but time. Go. Done. Running for the same amount of time. Do we know what that is? No clue. We do know they're equal. And that's something. Okay? Be okay with not having a value, but having a relationship. Okay? I don't know the number. I know, just deal with just put it down. Put down something. Okay? So we have time for the bear. I don't know what that is. I know. Time for the tourist. I don't know what that is either. I know. But you do know that they're equal. And that's a good connection. That's the setup. Almost. I mean, one more step. Okay, so I'm going to got my variables set up. Plug them into this equation. So I've got 6 meters per second for the bear is equal to 26 meters plus my displacement of the tourist over time. The fact that the bear and the tourist have the same amount of time, I don't have to make a distinction between the two. I don't have to put a little sub B and a sub T. They're the same. So I'm just going to say delta T. Okay, so that's the bear. The tourist, 4 meters a second, is equal to displacement of the tourist over time. Everybody see where I got that from, where that came from? At this point here, this is what I would consider the physics part. You're taking a scenario in life and you're representing it mathematically. This is the hardest part, in my opinion. It's the setting up. After this, it just becomes a math problem. Okay, the majority of the points are awarded for this part. Okay. Mathematically, looking at this, how many unknowns do I have now? 2. In order to solve for 2 unknowns, how many equations do I need in my system of equations? However many unknowns, that's how many variables. Sorry, how many equations. Okay? How many equations do I have? 1, 2. That is looking very promising. Okay? How do you solve for that? That is completely up to you. You've got options. You've been taught how to do those in math class. Elimination, substitution, setting them up. Like, I mean, you got, I can think of 3 right off the top of my head. Okay. So I'm going to show you a way. It isn't the way. It's a way to get the answer. Okay. Personally, if I can get this, if I can make the fractions disappear, get things out of the denominator, I'm going to do that. That's just a personal preference. Okay. So I'm going to bring delta t, I'm going to multiply delta t on both sides for this equation and also for that equation. So I've got 6, delta t is equal to 26 plus delta x of the tourist. Over here I've got 4 times delta t is equal to delta x of the tourist. And I just multiplied delta t on both sides. And now I'm like, all right, good, I got rid of those fractions. Okay. Again, this is a way, it's not the way. At this point, what I'm going to choose to do is I'm going to take this and I'm going to substitute that in for delta x. And I recognize that I just substituted away the thing I'm looking for, but if I substitute in for delta t, I'm going to get a lot of fractions, which is totally fine. It's just, it's messier. See what I did there? Okay, and now I'm just going to get my delta t's to one side. So I get 2, delta t is equal to 26, delta t is equal to 13. How are we doing? Okay. Is that my final answer? What did I just find? Time. What do I want? My displacement, my distance. Okay. So what do I want to do with that? Either plug it back in here or plug it back in here. That looks easier. I'm going to go with that. We got 4 meters per second is equal to delta x of the tourist over 13 seconds. And that's to be 52 meters. Bless you. Good. Big picture. I've got multiple objects. I had an equation or set up an equation for each object. That's what this was trying to get at. Okay. The intuitive route you're going for is to think of the person stationary and the bear running 2 meters a second, because the bear is running 2 meters a second faster than the tourist. So how long does it take the bear to cover that extra 26 meters? 13 seconds. And how far does the tourist run in that 13 seconds? 52 meters. Okay. That's fine if that came to you, but you need to describe it. Don't just write down 13, 52. Ta-da! Like, explain what you did. Okay. But also know that skill is going to abandon you next chapter. So this is the more tried and true approach. Okay. Okay, is everybody good with what I'm asking for? Okay. So this is what I'm talking about if there's more than one type of motion. Initially, you've got the jogging phase, and then you have the walking phase. There are multiple types of motion. So you need an equation for the jogging. Sorry, you need setup and an equation for the jogging, and you need a setup and equation for the walking part. All right. Start filling out variables. Okay. Given a time of 20 minutes, you're going to have a velocity or a speed of 4 meters per second. The unit, okay, this is a really important detail. Heads up on this one. The units of time have to be the same. Have to. You can either convert 4 meters per second to meters per minute, or I'm going to recommend going to seconds, converting your minutes to seconds. The default mode in this class is going to seconds. I'd highly recommend that. It's not illegal to go to convert that to meters per minute, but the big thing is the units have to be like the units of distance all have to agree, the units of time, they all have to agree, they all have to be consistent. Okay, so I need to convert this to seconds, so I've got 1,200 seconds for the jogging, and I also have 1,200 seconds for the walking as well. Now, define your average velocity. You need the total displacement over the total time. For the entire workout. So what that means is you did some running and then you did some walking. The total is going to be the displacement of the jogging plus the displacement of the walking. That's your total displacement. And your total time is going to be the time that you jogged plus the time that you walked. Does this make sense? Okay. What values do I have?
You have the time duration of both.
What do I not have? How am I going to figure that out? Well, you've got an equation. For the jogging, and you have an equation for the walking. I'll give you a 30-second head start. Beat me to the answer. when I mean beat me to the answer, like solve the entire problem. Are you serious, Mr. Smiley? We did all that work. I could have told you that like 10 minutes ago. The average is going to be 3 meters a second. I mean, that's just stupid. You see the setup. Does that make sense? Okay. Now, there's a second question. All right, to unpack this, how is this question different than the previous question?
Start by knowing total distance.
Okay. Have a conversation. How is this question we started with different than that question? Talk to your neighbor.
Same.
So yeah, how does this one different from the first question? because the first 10 miles you're going to take enough fire, which time it takes will be slower than 70 miles. Yeah. So the answer is not going to be 70 miles per hour slower. Just to get probably less.
Okay. How's this one different from that one?
This one, you start, the distance is divided by, the total is divided by distance, not by the time.
Here, you have equal distances. Here, you have equal times. The reason that this problem worked out is 4 meters a second, 2 meters a second. The average of those two is 3 meters a second. The reason that worked out is because they had equal amounts of time. That is why. We could figure this out mathematically. This problem, exactly the same procedure that we just did here. The only difference is we would know distance and we wouldn't know time. Okay? Conceptually, see if you can figure out the answer. More, less, or equal to 70 miles an hour. Go ahead and have a conversation. The reason why this was 3 was because these had the same amount of time. Question. How many people say A, less than 70? How many people say B, 70? How many people say C, more than 70? Okay. The reason why this was 3 meters a second was because they traveled 4 meters a second for 20 minutes for the same amount of time as they did for 2 meters a second. Which of these paths would you be traveling for a longer period of time? Going 60 miles an hour or going 80 miles an hour? 60 miles an hour. Is everybody okay with that? Takes you more time to do that 50 miles because you're going slower. So because of that, the average is going to be favored more towards the 60 than it is towards the 80 because you're traveling 60 miles an hour for more time than you're traveling 80 miles an hour. And you could go through this same math procedure and find that it's going to be like 68 miles an hour. You okay with that? Conceptually, that's why. Because you spent more time doing the 60 miles an hour than you did 180. That? So, for this, you wouldn't have to do all the math. But for this, you would have to do the math. Okay? Got a worksheet due tomorrow.